Algebra 2, set 92, boat in the river problems. Okay, so these problems involve a boat and a river. And let's just say we have a boat and the boat's speed is 11 miles per hour in still water. So it has a motor and it can travel 11 miles per hour. You have a river and the river is flowing downstream 3 miles per hour. So there are two scenarios. Your boat can either go downstream with the river or it can go upstream against the river. So we'll look at those two scenarios. First of all, we have our boat and the boat is going 11 miles per hour and the river's going 3 miles per hour and they're both going in the same direction. So we consider that downstream, and the total speed is going to be 11 miles per hour plus the 3 miles per hour. So that would be 14 miles per hour. That is traveling downstream. So now if we take it the other direction and we have our boat and our boat is traveling upstream 11 miles per hour, but the river is flowing downstream 3 miles per hour, we're not going nearly as fast. We have to take some of the speed off, and the way that we do that is we just do 11 minus 3 and we get the total speed to be 8 miles per hour. And again, that is upstream. So in all boat in the river problems, you have a downstream rate where the boat and the water are traveling in the same direction, so it goes faster, and so that is boat plus water. The rate of the boat plus the rate of the water. So then we have our upstream rate, and that's when they're going against each other. And so that's going to be slower because they're pushing against each other. So you have boat and your water. This time we're subtracting. You have the boat speed minus the water speed, and we're going to get the rate upstream. So that is kind of what you need to know about boat in the river problems. Other than that, they're just distance equals rate times time problems. The rate is a special rate though. So distance equals rate times time, and we have an upstream rate or equation, and we have a downstream equation. So for these problems, we know the rate upstream is b minus w, and we know the rate downstream is going to be b plus w. So in this case, we have 6 different variables. We have b, we have w, and then we have tu, td, du, and dd. Okay, so let's do an example. Robert and Clay could go 60 miles downstream in the same time it took them to go 20 miles upstream. If the speed of their boat was 8 miles per hour in still water, what was the speed of the current and what were their times? So the first thing that we can do is just write our two equations. We know d equals b plus w times t, and d equals b minus w times t. B plus w, again, you have a faster rate when you are going downstream, and you have a slower rate, b minus w, when you're going upstream. So let's list what information we have. We know that he can go 60 miles downstream, so the distance downstream is 60. He can go 20 miles upstream, so the distance up is 20. The boat goes 8 miles per hour, and the total distance up and down are the same. So we can take that information and plug it in. So 60 equals 8 plus w times t sub d, and then 20 equals 8 minus w, and since t sub u and t sub d are the same, we'll just plug t sub d in there. Okay, from there, let's distribute that t sub d. So 60 equals 8 t sub d, w t sub d, 20 equals 8 t sub d minus w t sub d. Now, we can eliminate either the 8 t sub d or the w t sub d. It's better to eliminate multiple variables, so we're just going to add these two equations. When we add them, we get 80 is equal to 16 t sub d, so that gives us our time downstream is 5. If we know our time downstream is 5, our time upstream is also 5, And now all we need to do is take it and plug it in to one of our equations. We can use this equation right here. 60 equals 8 plus W times 5. Now we just distribute. 60 equals 40 plus 5W, so 20 equals 5W, so W equals 4. 4 miles per hour and 5 hours. Let's do another problem. The steamboat Juby Fountain could go 70 miles downstream in 5 hours, but required 6 hours to go 48 miles upstream. What was the speed of the boat in still water, and what was the speed of the current? So this one's a little bit different as far as the variables that they give you. The very first thing I always do is write my two equations, and then the distance downstream is 70, and the time downstream is 5. The time upstream is 6, and the distance upstream is 48. And it's left to us to find the boat and the water. So we'll plug those in. 70 equals B plus W times 5, and 48 equals B minus W times 6. Multiply those out, and we end up with 70 equals 5B plus 5W, and 48 equals 6B minus 6W. Now, in order to eliminate here, we're going to have to multiply the top by 6 and the bottom times 5. So, 70 times 6 is 420, 5 times 6 is 30, so we have 420 equals 30B plus 30W, and then on the bottom we have to multiply by 5. So, we get 240 is 30B minus 30W. We can just add those together, and we get 660 equals 60B. So B, or the rate of the boat, is 11 miles per hour. Now that we know that the rate of the boat is 11 miles per hour, we can take it and plug it in. We'll plug it into this equation here. So 70 equals 5 times 11 plus 5W. 70 equals 55 plus 5W. Subtract 55, and we get 15 is 5W. So the water is 3 miles per hour. Okay, the water in the Flint River flows at 5 kilometers per hour. A speedboat can go 15 kilometers upstream in the same time it takes to go 25 kilometers downstream. How fast can the boat go in still water? So, the two equations again are, remember, downstream is faster, so we're adding rates, and upstream is slower, so we're subtracting the rates. We know that the water flows at 5 kilometers per hour. The distance upstream is 15. The distance downstream is 25. And the time up and down are equal. So 15 equals B minus 5 times T sub U. 25 equals B plus 5 times T sub U. We'll distribute those out. 15 equals B T sub U minus 5 T sub U. 25 equals B T sub U plus 5 T sub U. And then we'll add. Oh, actually in this case we're going to subtract because we want to get rid of both variables, the B and the T sub U. Because if we just added, then we'd have more variables than we needed and we wouldn't get a solution. So when we subtract, 15 minus 25 is negative 10. Negative 5 minus 5 is going to be negative 10 T sub U, so T sub U is 1. Now that we know T sub U is 1, we can plug it in right here, and 15 equals B minus 5. So B equals 20 kilometers per hour.